load. So this is 100 megawatt load. I hope you understand the question the same thing that I do. Each transmission line has the maximum transfer capability of 100 megawatt. Okay? Okay? And then the failure and repair rate of each component is given in the table below. Assume all components fail and repair independently. Find loss of load probability using random sampling method when number of sample is 100, 500, and 1000. Compare the simulation results with the exact value from analytical method. Can you solve it using analytical method? Right? Because this is 100, 100, the load is just 100, fixed 100. So it means that you need to find the probability of these three, right? So you need to first find the probability when generation probability when generation is 0. Right? And then you find the probability when transmission line 1 is 100, T2 equals to you can find these probabilities, right? Because you have given the mu and lambda. Now, I explicitly asked for the random sampling. What does it mean by random sampling? Random sampling is that you know the probability. Let's say this is a generation. This is a probability, state probability, not cumulative, okay? So if it's 0, maybe 0.01, then it means that it will be 100 at 0.99, right? Right? Okay. For the generator, for the transmission line, same thing, 100, 0, G1. Let's say this is 0.1 and this is 0.9. T2, 100, 0, 0.1, and 0.9. Okay. For the analytical method, you can enumerate, right? If you don't want to do anything, you can enumerate. In this case, you have 3 components. You can enumerate. T equals to 100, T1 100, T2 100. What is the probability? Loss of load? You know, is it loss of load? Right? And then the second case, G equals to 100, T1 100, T2 0. Loss of load. Right? And then go on. You have like only 8 states. Okay? So you can calculate this analytical way. This is what I mean by analytical. Add the probability. That's it. What is the simulation? For the simulation, random sampling simulation. Random sampling simulation means that you first draw a random number. In this case, how many random numbers you need to draw for one system state? How many random number? If I want to construct a system state, how many components are there? Huh? I heard 4. What is the fourth one? 3. You have generator, you have transmission line, right? You have 3 components. transmission line 1 and 2, right? We have 3 components. So if the question asks in a different way, if the question say that it supply 100 megawatts load, it supply 100 megawatt load with the probability 0.9, and it supply 100 120 megawatts with probability 0.1. If that is the question, then it means that you have four components that you need to draw random numbers. But this case you have only 3. Why 3? Because these are associated with its distribution. So these are the random variables. These are the 3 random variables in your system. So with these 3 random variables in your system, what you do is, it's given that find this when number of sample is 100, 500, and 1000, right? So what you do is you write for loop. For I equals to 1 to 100. Do what? Do what? First, draw a random number. Okay? What are the random numbers? G, generator. T1, transmission 1. T2, transmission 2. Right? These are the steps. First, draw the random number. Let's see a random number of generator. 1 equals to 0.789. Of the transmission line 0.001. Transmission 2, 0.123. What do? Look at the table. Look up your table. If the probability, now this depends on how you assign the random number to your state selection. Remember what I told you? In any case, the probability will come out the same thing. You can assign that if the random number greater than or equals to 0.01, then I will take out this state. Right? I'll take out this state. If it's less than 0.01, then I will take this state. Right? Right? Okay. So no. Random number greater than less than or equal. Take this one. Higher chances. Okay? Right? Has higher chances of happening. That one. Okay? In any case, you look into this. Maybe drawing this picture. This is 0.01 and this is 0.99. Right? So depending on the random number, if you select it from this area, it should select out this state, 0. And if it's coming from this area, it should select out state 100. Okay? So that's a concept. So let's see if it's this case, it picks out the state 1, which is generation 100. If it's T, it selects out the state of 0. If it's this much, it selects out of the state 100. What do? Number 2, you calculate, evaluate system state. How? If generator, you well, the easiest way is to look at if generator is, you can write the if then clause. If generator is greater than or equal to 100 and T1 is greater than or equal to 100 or T2 is greater than or equal to 100, right? If you write this case, it means that if you have enough transmission line and you have enough generation,